In this video, the learning target I'm going to talk about is I can convert standard form to vertex form. So standard form, once again, is just the form of a quadratic where you have an x squared term, an x term, and a constant term. And vertex form is the transformation form where you have your stretch, your horizontal shift, and your vertical shift. Okay. So to do this, the method we use for converting standard form to vertex form is to complete the square on the equation. So notice in number one here, I have y equals x squared minus 12x plus 7. And what I'm going to do is I'm just going to complete the square. And you'll notice that that transforms this equation into vertex form. So when we complete the square, we get rid of the last term so that we can replace it with a number that will allow us to factor the quadratic. So I'm going to get y minus 7 equals x squared minus 12x. Okay, so I've gotten rid of the last term, the c term, and I've moved it over out of the way onto the left side. Then what I'm going to do is I'm going to add some number to the end of this quadratic so that I can factor this right side into a perfect square. Okay, but if I add it to the right side, in order to keep the equation balanced, I need to add it to the left side. Now, the way I get this number that I'm going to add to both sides is I take half of the middle number. Okay, so this negative 12, I take half of it. Well, half of negative 12 would be negative 6. And then I just square that number. So if I take negative 6 squared, negative 6 times negative 6 is 36. Okay, so I'm just adding 36 to both sides. And once again, that's just half the middle squared. What I can do then is I can simplify the left side, which is y minus 7 plus 36. Well, that's going to be plus 29 equals, and then now that I've added this number, I can now factor this, and it should factor into a perfect square. So if I do this using FOIL, I'm asking myself what times what gives me the first term? Well, that's x times x. Then I ask myself what times what gives me the last term? Well, 36 could be 1 and 36. It could be 2 and 18. It could be 3 and 12. It could be 4 and 9. And it could be 6 and 6. Now, I want the pair that's going to give me negative 12 in the middle. And you'll know that it's going to be the pair that gives you the perfect square. The numbers are going to be the same. So it's going to be the 6 and the 6. And I'm going to want them both negative, right? Negative 6 times negative 6 is positive 36. And when I combine negative 6x with negative 6x, that will give me the negative 12x. Okay. Whenever you complete the square, just know that the two parentheses should look identical. Okay. You're completing a square, and when you take something times itself, that gives you that same thing squared, right? X minus 6 times x minus 6 is x minus 6 squared. That's why we call it completing the square, because you're getting a perfect square. And then we have y plus 29 on the left side here. Now, I'm actually almost done with the problem. All I need to do now is just subtract the 29 back over, and I get y equals the quantity x minus 6 squared minus 29. And you'll notice this is now in vertex form. The a that's not written here is technically a 1, so I'm going to write that in. So the a is a 1. The h is a 6, and the k is a negative 29. Okay, so this is now in vertex form. And if I was asked to find the vertex, so if someone said, well, what is the vertex of this equation? Well, negative 6 takes me right 6, so it's going to have an x coordinate of 6. And then it's shifted down 29, so the y coordinate would be negative 29. That would be the vertex for this equation. Okay, so once again, we can just convert standard form to vertex form by completing the square. Let's look at one more example of doing this. So in number 2 here, I have y equals x squared plus 4x plus 1. I can subtract 1. Okay, I'm moving the 1 out of the way so that I can replace it. So I get y minus 1 equals x squared plus 4x. And then I once again want to just add a number to the end that'll allow this to factor into a perfect square. And whatever I add to the right side, I have to add to the left side. Now, the way I get this number is I take the middle number, which is 4. I cut it in half, which is 2, and then I square that number. Well, 2 squared is 4, right? So if I add it to this side, I also add it to that side. Once again, I can simplify the left side. That's going to be y plus 3 now, right? Because negative 1 plus 4 is 3. And I can also factor the right-hand side. What times what gives me the x squared? Well, that's just x times x. What's going to multiply to 4 and add to 4? Well, that's just 2 and 2. Notice once again that anytime you complete the square, these will be identically the same, which means they form a perfect square when you multiply them, right? X plus 2 times x plus 2 is x plus 2 squared. And then I get y plus 3 on the left. And then my last step, once again, is just minus the 3 back to the other side of the equation. So I get y equals x plus 2 squared minus 3. And then this is vertex form. And once again, the a is not written here, but remember, that's really a 1 in front. So the a is 1, the h is positive 2, and the k is negative 3. And once again, if we were asked to find the vertex, well, we could do that, right? The x coordinate, it's shifted left 2, so that's going to be negative 2. It's shifted down 3, so that's going to be negative 3. Okay, but the big idea, once again, is that if you want to convert from standard form to vertex form, just complete the square on the equation, and it will do that.